Oh, it maybe did get scared. That's right. See, it's getting you prepared to give shots to young kids when you get your pharmacy degree. Yeah. Go with that? Okay. Fair enough. But aldehydes, you can say you're going to hit yourselves over the head when you see that. Yeah, it says it right here. Okay? So at the end of stage 1, so we're keeping this simple. You could even say methanol will do that. Okay? So what we see happening then, oxidize it, and I don't have an answer. Well, why does it go from an aldehyde, or excuse me, a primary alcohol all the way to an acid then? And I really don't have an answer for that. But other than it goes in 2 stages. So again, this is any primary alcohol, and there could be other derivatives branching off of here. As long as this is on that first carbon, it's a primary alcohol that will get oxidized to an aldehyde and continue after stage 1 into stage 2, where it's converted then to an acid. Okay? So again, why that is, I really don't have an answer at this time. So just recognize that what we see happening is primary alcohols added with an oxidizing agent is going to go through 2 stages. 1, to an aldehyde, and 2, to an acid. So secondary alcohols, when they are oxidized, is something altogether different. So looking at this, do you think, is it just a mistake that we do not see organic acids down here, or is it not possible for them to oxidize to organic acids? What do you think? And that would be a proper response. But to answer that, we'll try to point you into the right direction. Okay? So how do we know that this is a secondary alcohol to begin with, other than this primary? Yeah, there's 2 carbons attached to that. Okay? So what we see happening is, as this is reacted with one of these oxidizing agents, okay, what do we see is formed then? Ketone. Okay? Because that double bonded oxygen is somewhere other than up here, which is on the end, or the first. The first is probably a better way of looking at that. So when this gets oxidized, the secondary alcohol, it forms a ketone. So now, why can't this form an acid? Acids have to be on which carbon? It has to be on the first. It can't be anywhere other than the first. And one way to look at that is, what makes this organic family an acid? A double bonded oxygen and a what group? An OH group. Okay? Is there anywhere to attach an OH group on here? And the answer is no, because it's already got its 4 bonds. It can't do that anymore. So all the bonds are available or taken up by that double bonded oxygen. Okay. So now, what we see happening with that of, but one of the things to keep in mind, just like with your flow charts for aromatic compounds, you had to see where you were starting. If you had toluene, or maybe a phenol group, you would not start in the same place every time unless you had just plain benzene. So again, how you have to interpret that chart, okay, which I don't see that, I think it's over on my other desk, but notice one of the things that could happen is during some of these problems, you could be starting with an aldehyde. Okay? There's nothing improper with starting after stage 1 has been completed. It's not going to go through any more than just one more stage of oxidizing into an acid. Okay? So the big point to take home is recognizing the difference between these alcohols even though it's the same oxidizing agent, primaries do 2 stages, secondaries only do 1. So how you remember that, I really don't know, other than utilizing this chart. Okay? So ether formation. Okay? You could say, I don't want to do this ether. That was a Monday morning funny. Ether. Okay. So what we see happening then, nothing's changed when we're talking about some of these alcohols. For secondary alcohol, up to this point, if we had seen a dehydration reagent, which is what? What's a dehydrator for alcohols? Sulfuric acid, okay? But the reason we bring this in, okay, is because when these are at different temperature ranges, okay, notice what we see here. It's written in purple, okay? It says ether formation of primary alcohols. And down below it says dehydration of secondary alcohols. And that's why we wanted to spend so much time recognizing the differences between primary and secondary alcohols, because their pathways are different. Okay? So at 140 degrees with a dehydration reagent, okay, with that of, and I need to get a secondary alcohol on here as well. Oh, no, I don't. Sorry. If it's at this temperature range, it's no surprise, and we can't do methanol, can we? It's got to be ethanol again, because we can't form a double bond with just one carbon. So what we see happening is at 180 degrees, okay, we'll just do it with 2 carbons in length each time. Okay. And there's another one where I really do not really have an answer, but notice what you see happening is ether formation of primary alcohols. So you have your dehydration reagent, H2SO4, but it's at 140 degrees. Ethers are going to form. And what you do is, if it's 2 carbons in length, you put 2 carbons on one side, 2 carbons on the other, and then the oxygen is in the middle. That's an ether, is where you have a single bonded oxygen anywhere other, well, it can't be on the end. It's going to have to be a double bond then. So that is an ether. You see a primary alcohol, then it forms an ether at 140 degrees. Okay. Then one last thing I would like to do is look on the same page you had your oxidation of primary and secondary alcohols. If you notice, what's true about the top of this page? Does some of that information look familiar? Probably not using this, but just remembering it. Because we've done this. This was in chapter 3, okay? And it's just alkylation, halogenation of alkanes, and then hydration and halohydrogenation. That was Markovnikov's rule. So that's what you're doing with the blue there, okay? So some of this we've been applying, we just didn't use these flow charts. Now we're going to have enough information that to try to keep all of this stuff straight would probably be pretty tough. So that's why you have this flow chart to work with. Okay? Was this a bit overwhelming, or left side? Are we okay? Middle? Right? Okay. So we'll continue with some of this information, and we'll pick this up tomorrow, and then we'll have another paper for you. All right, so that's it for today.